Hello, welcome back to my another session. In this session, I have a talk about the energy flow in the ecosystem, and this is the second aspect of the function of the ecosystem. The flow of food or the nutrient and the flow of the energy in the ecosystem. These two are the functional aspect of the ecosystem. Suppose that this is the different members of the ecosystem. This is the model of the freshwater ecosystem. The energy enter into the ecosystem through the green plants, through the autotrophs or the producers. The producer, they have the green pigment, that's why they can trap the solar radiation and convert into the food energy or the chemical energy, and such energy or the food which transfer to the herbivores by feed or grass, and such herbivore become the food of the carnivores. So in this way, the food energy transfer from the autotrophs to the herbivores, from the herbivores to the carnivore, then the top carnivores. So the flow of energy, it is governed by the two laws of the thermodynamics. So before going through the laws of the thermodynamics, you have to know what is the energy. Energy, the ability to do work, is known as the energy. And the energy is two types. One is the kinetic energy and another is the potential energy. Potential energy means the stored energy, and the kinetic energy, it means the energy in movable condition. It means that the energy which present in the food in a form of stored manner, which is known as the potential energy. And such potential energy which convert into and transform into kinetic energy because of for doing of the different works or the metabolic activities of the organisms. And the flow of energy in the ecosystem which govern the two laws of the thermodynamics. According to the first law of thermodynamics, it tells us that energy can neither be created nor be destroyed, but it can transform into one form to another form. So here, this law here, you see that this law actually obey this law, first law of the thermodynamics. This is the radiant energy comes from the sun, and such radiant energy convert into the food energy, and such food energy again transfer to the herbivores or the primary consumer to secondary consumer, and subsequently top consumer. So that is the conversion of the solar energy into the potential energy or the food energy or the chemical energy. So according to the second law of the thermodynamics, there is no transformation of energy unless the concentrate form of energy convert into dispersed form. And how the energy actually flow in the ecosystem, we'll study under such model, and this model actually given by the LINDEMAN'S in the year 1942. And this model which shows the energy flow in the lake ecosystem or the freshwater ecosystem, and this is the single channel energy model. So this is the single channel energy model. We will clear about the energy, how the energy flow. Suppose the first we start from this side. So the 118872 gram calorie per cm square per year. Such amount of energy actually enter into or trapped by the autotrophs, but only the autotrophs only trap the 111 gram calorie per cm square per year amount of energy. So the efficiency of trapping of energy here is 0.10%. So only autotrophs store only the 111 gram calorie per cm square per year energy in a form of food or in a form of the plant product. And such energy transferred to the herbivores by feed or the grazes. So the herbivore feed the autotrophs and only 17% of energy transferred to the herbivores. And herbivores only store the 15 gram calorie per cm square per year energy. It means it is the 17%. So in autotrophs, the plants or the green plants, they utilized the about 21% of energy or the 23 gram calorie cm square per year energy for the respiration, and about more than 17% or the 79.5% actually not utilized by the autotrophs, and 3.4% or the 3 gram calorie per cm square per year energy utilized by the decomposition, or such amount of energy actually decomposed by the decomposers. So only 17% transferred to the herbivores, and herbivores only capture or the trap the 15 gram calorie cm square per year energy, and this is known as the gross product. Here also, how much energy autotrophs trap? The 111 gram calorie cm square per year. This is the gross product of the autotrophs. Herbivores, these are the animals. Again here, the very much amount of energy actually utilized by the growth, respiration and the reproduction. So about 30% of energy utilized by the herbivores, and this is the 4.5 gram calorie per cm square per year. And 17% it is not utilized by the herbivores, and 0.5 gram calorie per cm square per year. This amount of energy actually utilized by the decomposers. And such herbivores, when become the food of the carnivores, only the 3 gram calorie per cm square per year energy transferred to the carnivores. So the carnivores only store the 3 gram calorie cm square per year energy when the carnivore feed on the herbivores. So here there is the 15, but here there is the 3 and there is the 111. So gradual reduction of the or decrease of the energy takes place when it transforms from one trophic level to another trophic level. So in case of carnivores or in case of second consumer, we find that 1.8 gram calorie per cm square per year amount of energy utilized by the respiration, growth, reproduction, and the very trace amount of energy actually utilized by the decomposer, by the process of the decomposition, and very trace amount of energy transferred to the top carnivore or the second carnivore when the second carnivore feed on the first carnivore, and the amount is the very trace amount of energy transferred to the second carnivore, and 1.2 this amount, the very less amount means 1.2 gram calorie per cm square per year. This amount of energy, it is being not utilized by anyone from the carnivores. So you find that there is the gradual reduction of energy. So here, this is the energy flow, this is the unidirectional. So energy here, we know the energy comes from the solar system or the sun through the autotrophs. So autotrophs is the door through which the energy enter into the ecosystem, and such energy transformed from one trophic level to the another trophic level in a form of food or in a form of the food energy by the feeding or being fed or being eaten by the others. And so this is the flow of energy, and this model actually proposed by the Lindemann. That's why it is known as the Lindemann's model of the energy flow, and this model is very famous when we discuss about the energy flow. And this model actually proposed the how much of amount of energy produced in the freshwater ecosystem, and how much of energy actually utilized and unutilized by the different members of the ecosystem. So I hope you all clear about the energy flow in the ecosystem, and this much is sufficient about the environmental studies or the